So one thing that I'll ask you to do, because I'll sometimes forget, is to remind me to record. You can tell I'm recording if there's this red button, this red stop button up here on the toolbar. You can barely see it on that screen. If you don't see that, say, excuse me, can you remember to record the lecture? And even if you're not sure, just it's okay to ask and say, oh, by the way, are you recording? Did you remember to do that? Right now we're recording. Don't be afraid to ask a question. Your voice will be pretty much inaudible on the recording, so you don't have to worry about being on YouTube. They won't be able to hear you. They'll just be able to hear the answer to your question. Okay. So we want to learn about Python. So let's, and we're going to do this from the command line. So here I am in my working directory. How's the font size on that? It's huge from my point of view, but maybe not for you guys. Here I am in my working directory, and I'd like to show you guys something. So I'll fire up Python. And for now, just the plain old version, no arguments. You'll see that when I fire up Python, whatever that means, I get a little bit of information about the version of Python that I'm running, and I'm running 2.7.6. Those of you who know a bit about Python know that there is a Python 3. It's actually more than 5 years old now, so you may wonder why I'm still running this old version. The main reason is that despite being around for 5 years, not every library is compatible yet with Python 3. In particular, the Pygame library that we're going to use to make games later, there are compatible versions, but you may have to recompile, and it's going to cause a bunch of headaches if we try and use Python 3. There'll be a lot of people who just run into difficulties setting things up. And one of the points of using Python is that things should not be difficult. You shouldn't get stuck in roadblocks that are technical things. It should just be about problem solving. Yeah?
My download version is 2.7.8.
That's fine. As long as the major version is 2.7, you should be good. Okay. All right. So I was at the command line prompt. I typed Python, and now I'm at this different prompt. 3 carets like this is what you see. This is something that we'll see all the time. And this is Python running in what's called interactive mode. So you can just now type in Python statements, and they'll get evaluated, and their results will get printed. So if I type 2 plus 2, that's a valid Python statement, and it evaluates to 4. So not too surprising. 3 times 3, that evaluates to 9. No big surprises there. 2 plus 2 minus 1, what's that? 3, great, so far so good. How about, let's say, 5 plus 2 times 2. What's that? 9. So how did you know it was 9? Why is it not 14? Bedmass. So Bedmass, for those of you who maybe weren't educated here in North America, it's our little mnemonic that we use for remembering order of operations. Stands for brackets, exponentiation, division, multiplication, addition, subtraction. And actually these things are sort of grouped together. Division and multiplication, addition and subtraction go together. Brackets gets the highest priority, and exponentiation is sort of all by itself there. And so addition and subtraction, they're sort of at the bottom end of this list. Division and multiplication are higher up, and that's why this 2 times 2 happens before 5 plus 2. Right? If we wanted it the other way, we could use brackets, and then we get 14. 5 plus 2 is 7, and then we multiply it by 2. So, so far so good. Well, there's some other things in BEDMAS that we haven't seen. Exponentiation, for example. So let's say 3 star star 3. That's 27. So Python, unlike some other languages, actually includes an exponentiation operator. It's denoted with 2 stars. So this is 3 to the power 3, which is 3 times 3 times 3. Maybe I shouldn't use the same argument on both the left-hand side and the right-hand side. So let's say 2 to the power 4. What's that? 16. That's 2 times 2 times 2 times 2. So there's four 2's there. 2 multiplied by itself 4 times. So it does exponentiation. Yep. The caret does not work. Well, the caret will work, but it actually means bitwise exclusive OR. So it's not what you're expecting. Okay, good. So we have exponentiation, and we can check that it fits in, where we think it would. 2 plus 2 to the power 3. What's that? 10. 2 to the power 3 is 8, and that happens before we add 2 and 2 together because exponentiation is way over here on the left in this order of operations. Okay. Let's try this one. 2 to the power 300. Is that going to work? There it is. 2 to the power 300. It's looks like it's about a 95-digit number. Aha. So good observation. We got this number, and if you've worked in other programming languages and tried to do something like 2 to the power 300, you often get some strange result that doesn't look like this. It's usually a much smaller number that you get. It might even be a negative number, which really doesn't make sense. Python is smart about integer arithmetic. If it needs to, so normally integers can't get too big in most programming languages. Usually not bigger than about 2 billion or so. This is much bigger than 2 billion. This is I don't even know what the name is for a 90-digit number. And so when Python sees that you're doing integer arithmetic that's going to give you a number that's too big for integers or normal integers, it upscales them to long, which is what this L denotes here. So this L at the end of this thing is just telling you, yes, this is the answer. And by the way, this is a long. This is not your normal integer. It's getting pretty big. I've had to use a special representation that can handle really big integers.
So you don't have to declare your variables in Python?
No, there's no variable declarations, and there's no types of variables either. So it's a very loose, easy to use language that way. It's also really easy to shoot yourself in the foot. We'll see some examples of that. How about that? What does that evaluate to? Yeah. So 2 suggestions have been thrown out, 0 and 4. 4. So I wrote it in a misleading way, and you too can write things that are misleading. I recommend that you don't. All I did was added a bit of extra space around the minus sign, so it looked like that those was farther apart from its arguments, but that makes no difference at all, right? That space means nothing. That's exactly the same as doing this. And addition and subtraction have the same level of precedence, and when there's a tie like that, things are done left to right. So you get 2 plus 2 is 4, minus 2 is 2, plus 2 brings it back up to 4. So it's not 2 plus 2 minus 2 plus 2, so it's not 4 minus 4, it's just this minus 2 in the middle of the calculation. Division and multiplication behave the same way. They're read left to right like that. And this is the kind of thing that can throw you off, especially if you use misleading spacing like this. When possible, if you're writing code, it's okay to use spacing, but try and use it in a way that actually is suggestive of the order of operations. So something like 2 times 2 minus 2 times 2, 2 times 2. That's nice looking code because it gives you it makes it easier to see what the order of operations is. So look out for that kind of thing. All right. So I don't know if you guys, well, I do know you guys have done a little bit of trigonometry at some point. Okay. A little bit of, you know about circles? You know what a circle is? Okay, good. So let's fire up our editor and let's write a little bit of code to do something with a circle. So let's say that I would like to be able to compute the area of a circle.
Is there a pi variable in here?
Yes, we'll see that very soon. So let's say I want to compute the area of a circle. What do I need to know about the circle? So a lot of different things can tell me the area, the radius, or the diameter. Let's say that we want we want to know this area of a circle whose radius is r. Okay. So what is the area of a circle of radius r? Pi r squared. So turn pi r squared, like that, right? Pi times r squared. And we can help the reader by making some suggestive spacing so that we know that the squaring of r happens before we multiply by pi. Okay. Is this going to work? This code? So let's see what happens if we try and run this. Well, that's okay. If I run in, so what I've done here is I fired up Python. I told it to use this input file that we just created called day1.py. And I passed it an argument that said, after you've read day1.py, stay in interactive mode. Don't just quit. Let me enter some commands. So now this file has been read. This definition of this function is there. It's ready for us to call. And so let's ask for the area of a circle of radius 2. And what we get is an error. You're going to see a lot of these. Anybody who programs sees errors constantly like this. Learn to read them. So what we get is what's called a traceback that shows us where the error happened and all of the functions that were called along the way, as well as some more information about the error. So this says standard in the code that I was just typing in where I asked for this area of this circle. And that called this code area of circle. And in that code, there was this line that says return pi times r squared. And that generated what's called a name error. It says this name pi is not defined. It doesn't know what pi is. So it doesn't seem to know what pi is. So let's avoid that. So what can I use instead of pi? Yep. We'll see that shortly, but if I don't want to do that yet, let's say 3.14. And now let's run it again. So that's right, kind of. You probably know that pi you can't write down. It's an irrational number, which means you can't write it down with any finite number of digits. So 3.14 is just an approximation, and we can extend that to 3.14159. We could even go better and ask Google for the value of pi. Bloomp. Oh, here's a good one. 100,000 digits of pi. We could use all of those. Well, that's interesting. The Wikipedia article manages to only write down this version here. But if we go somewhere else, we could get 100,000 digits of pi. So let's use the first line from that table. There we go. Not so pretty, right? We don't really want to paste that everywhere we need pi in our code. So we could define a variable that has pi for us. We'll see that there's already one in the math library. Let's leave this one. I really hate lines of code that go across more than one line, so let's only take that amount of precision there. And now we get a more precise answer. Not quite as precise as we gave enough information for. We get something that's a little bit truncated, and we'll see more about that in a second. All right, good. So we've seen that. If we wanted to keep pi around, well, we could do it this way instead. Define a variable called pi. And then use that variable instead. So at any point in time, you can define a variable, give it any name that starts with a letter, doesn't have any spaces, and uses only letters and numbers. So my pi equals, a really rough approximation would be 3, for example. And then that's ready for me to use. So variables are really easy to define. You just assign a value to a name, and you get this new variable. Here we'll assign this value to this variable pi. All right. So any questions so far? Yep. How did I open which other window? The window with the code. Okay. So you'll constantly see me moving back and forth from the command line and the Python interactive interpreter. So when you see these 3 carets, like you see here right now, that's the Python interactive interpreter. When I leave that, you'll see something like the name of the current directory printed here. So this is the command line. And I have an editor on my system called gedit, which is what I use to fire that up. It's already open, so it won't open again. It'll just open an empty document now. So I just ran gedit. Between the two windows?
Yeah, just in there, how do you have the three carrots there and just doing register?
So for that, now I'm at the command line. So now I type Python, and now I'm back in the Python interpreter. So I'm running a command called Python, which fires up this interpreter. And to get out of Python, sometimes that can be frustrating as well. There's a few ways to do it. The cleanest is to call some function called quit, and that'll just take you right out. I shortcut that by hitting Control D, but that doesn't work on all systems. Yeah. You can only have gedit if you're on a Linux system. Otherwise, the first exercise in the book, exercise 0, will point you to reasonable text editors for Windows or Mac OS. gedit is not a fantastic text editor. It's just the one that happens to be the sort of default under Ubuntu Linux. Yeah. Using what? G-E-A-N-Y. I don't know. If it's a decent editor, sure. Anything which is just a text editor, not a word processor. The editor that you use in this course, not a lot will be required of it. This one knows about the Python language, so it can do some syntax highlighting, showing me special Python keywords and variables and so on, but that's it. Okay, good. So let's work on another function. The area of a triangle. So you guys remember how to compute the area of a triangle? Yep. What's the formula? The base times height divided by 2. So this is a function then that should have two arguments. For the area of a circle, we needed one argument, the radius. For this one, we need to know the base and the height. So function area of triangle should take two arguments, let's say b and h, and it should return the base times the height divided by 2. And so that's a function that we think will compute the area of a triangle. Yep. No, this should be okay. I mean, it'll do the base times the height and then divide the result by 2. Even if it did the other way, if you divide the height by 2 first, then it'll still work. So that's not a problem. But there is something we should look at a little bit more carefully first. So for those of you with programming experience, 3 divided by 2. What is that? 1. 1.5. If we were doing math, it would be obvious. The answer would be 1.5, right? But we're doing programming, and if you've done some programming in other languages, well, it's actually not obvious, because sometimes when you take two integers and you divide them, the result has to be an integer, so that 0.5 kind of disappears. Who wants to guess what this will do? 1.5. So here's where I have to give you a little history lesson about Python. In early versions of Python, they decided that it should not work this way, that it should work like other programming languages, that 3 divided by 2 should give you just 1. It should be just integer division. After a while, they learned that that was a horrible mistake in the design of Python. It makes things, when you combine that with the other aspects of Python, it makes it very hard to write code that works for numbers, for numeric calculations. So they decided that they need to change this behavior and that 3 divided by 2 should really give you the right answer, 1.5. Now, something that you missed is when I fired up Python this time, I actually gave it an extra argument, and actually 2 extra arguments, minus q new. This tells Python that I would like to use the new rules for doing division. I don't want to use the old rules, which would give me crazy answers like 3 divided by 2 equals 1. If I leave that out, and I never want you to do this, because I think 3 divided by 2 should be equal to 1.5, then I will indeed get 1. This will be confusing to some of you, and this is a mistake that many of you will make. So for a while, I would like you always, when you fire up Python from the command line like this, to use Python minus q new, to avoid this crazy arithmetic in which 3 divided by 2 is 1. Yeah? Python 3 finally threw out this crazy old version of arithmetic. But Python, all versions of Python up to 2.7, still by default will use the old rules. So you need to tell them not to. If you have Python 2.7, which is what I have here, and you don't tell it to use the new rules, it'll use these bad old rules where 3 divided by 2 equals 1. Yep. Why did they do that to begin with? They weren't thinking. Every other programming language did it, so they just did it the same way. And for other programming languages, it's not such a problem. The reason being that for other programming languages, you tell them typically what the types of variables are, but when you mix the two, not knowing what type of variable is and having this weird division, it causes all kinds of problems. So let's, we can try that out. So let's say we go with Python the old way, and let's test out our area of triangle function. So let's say the base of the triangle is 2, and the height of the triangle is 1. What should the area be? 1. If the base of the triangle is 3 and the height is 1, what should the area be? 1.5. But that didn't work. And that's because internally, this division ends up being, 3 times 1 is 3. That's an integer divided by 2. Well, it's doing this crazy old division where 3 divided by 2 equals 1. We don't want that happening. So there's a couple of things we're going to do to always avoid that. When we run Python in interactive mode, we'll use minus q new. So now if I ask what the area of a triangle is, we get a reasonable answer. So that's one form of protection for this, using minus q new. Even better, when we make a file like this that contains Python code, we'll put a little bit of voodoo at the top and tell it that if you're running under an old version of Python, I want you to time travel into the future and import the definition of division. And then it'll give us this new version of division. Yep. If you're having trouble running your code, we can look at it after class. Check that you're actually in the interpreter versus at the command line. That's a common mistake. Okay, we'll look at it after class. Yeah. Yes. If you go back to the old way, you can always tell it just like this. If I say 3.0, now that's already a number which you're telling Python this isn't really an integer, this 3.0. It's one of these numbers with a fractional part. It's called a floating point number. And so anything calculations you do with this, you should use floating point arithmetic. And then you get 1.5. But that doesn't help. That still leaves a lot of room for errors in things like this area of triangle function. So better to just use the new rules. They make more sense. Okay, so there are these things, different kinds of numbers. There's integers we've seen now. There's long integers, which just appear when you do integer calculations that get too big. And then there's these other numbers with fractions in them. These things are called floating point numbers. And they're substantially different. Sometimes I like to convert. I might want to convert between the two. So for example, if I have an integer and I would like to turn it into a float, so let's say x equals 5. What's the value of x? X is equal to 5. That's an integer for sure, but I can ask, what's the value of x as a float? And that says it's the float 5.0. Similarly, if I have y is equal to, let's say, 3.0, what's the value of y? That's one of these floating point numbers. If I want to see it as an integer, I can ask it to be converted to an int, and then I get the integer 3. And that's not a lossless procedure, right? Because if y was 3.5, and I ask you to convert it to an int, it's just going to do the most reasonable thing that it can do, and it's going to give me back 3. Okay. So converting between ints and floating points, not so great. Things can get lost along the way. Errors can be made. And in general, when you work with these floating point numbers, there's room for errors. Here's one. So let's say 3.0 minus 1.0. What do you think that is? 2.0. 0.3 minus 0.1. What do you think that is? 0.2. It's the same calculation, right? It's just different by a factor of 10. Oops. Floating point arithmetic is not so accurate. It's not perfect. So 0.3 minus 0.1 gives you a number that's pretty close to the right answer, 0.2, but it's actually not quite there. This can cause all kinds of problems, so be aware of it. And in general, if you can do calculations that only need to use integers, try and do that. If you start working with floating point numbers, you can run into issues like this. And these things are subtle and often unpredictable. For example, what is 1 divided by 3? What is 1 divided by 3 when you use real math? Zero point 0.333333, repeating threes. So we don't get an infinite string of threes. That would be good. Otherwise, my computer would crash just by printing it out. So 1/3 as a floating point number gets represented as 0.333333. What about 1 plus 1/3? As you expect, it's 1.33333333. How about 2 plus 1/3? Nope. Finishes, you get a number that finishes with a 5. Another example of floating point inaccuracies. So these things are a bit tricky to work with, floating point numbers. In general, if you're trying to make real decisions where you're comparing if two numbers are equal, that can lead to a lot of problems because you would really like 0.3 minus 0.1, you would like that to be equal to 0.2, but it's actually not true. So be careful with that. That'll come up a little bit more later in the course. If you can avoid them, don't use floating point numbers. All right, so we've got this nice version of the division operator, which does what it's supposed to do if we always use this new division. Sometimes, though, you'd like to use old division. And, well, they kept that around, and they just gave it a new look. If you do this // operator, then you get the old integer division operator. So division without any fractional part. So what's 5? And I pronounce this operator as div instead of divided by. What's 5 div 2? It's 2. And that's because 5 divided by 2 is 2.5. We throw out that fractional part, that 0.5, and just keep the integer. Yeah. No, // I think will still work in the old version, but it does exactly the same thing as well. With integers, it does the same thing as slash. Yeah.
You do integer division like that, they always round down?
Yes. Yes, the integer division always rounds down. Let's see. We did 3. So 2/3 is 0.666, but 2 div 3, it doesn't round up to 1 because 0.66 is closer to 1. It truncates. So it's division with truncation, not rounding. Okay. Good. So if you really want it, you can get that old kind of division. Sometimes it's useful, and it's in particular useful with something called modular arithmetic. So we saw, for example, that let's say 7/3 is 2.333. 7 div 3 is just 2. So this div operator gives you the integer part of a division, and it throws away any leftover. There's a complementary operator called the mod operator. It's denoted with a percentage sign, which does the division and keeps only the remainder, keeps only what's left over. So when you take 7 and you divide it by 3, you get 2 and a 1 left over, a remainder of 1. If you take 8 and divide it by 3, you get 2 and a remainder of 2. Right? So you can pull out both parts of this division that happen. You can get both the whole part of the division and whatever is left over, whatever was not included in that whole part. So let's see something useful that we could do with this. So how many of you have used a microwave oven before? Good. How many of you have, on the timer on the microwave, when you're cooking something, sometimes you have to press buttons before, sometimes you can just enter a time straight away. How many of you entered 90 seconds? Yeah? So you press 90, and that shows up, a 9 and a 0 appears. And then you press start, and what happens? That depends on the exact implementation of your microwave. I've seen both kinds. Some of them will count down, 90, 89, 89, 88, and so on, all the way down to 0. Others, the moment you press start, instead of saying 90, they'll show something like this. 1:30, 1 minute and 30 seconds. So how are they doing that? And the weird thing, the slightly annoying thing about microwaves is if you enter 130, that's usually exactly the same thing as entering 90. You'll get the thing will cook for 90 seconds, 1 minute and 30 seconds. So how do they do that? So internally, what's typically happening is the time that you're cooking for is represented as one integer. It's the number of seconds that you're still cooking for. And it's just the display that shows you it in a fancy way, which shows you minutes and seconds. If you're really crazy, you might microwave something for hours. I don't know if microwaves support that. But it's really a trick of converting seconds to something that looks like minutes and seconds. So let's see if we can do the microwave trick. So let's say seconds to, let's say, ms. And this is, function name is a bit long. So I'll give you a time in seconds, and I would like you to tell me what that time is in minutes and seconds. So first of all, how do I figure out how many whole minutes there are? So 90 seconds. That's the div operator, right? So 90 seconds divided by, or not divided by, but div 60, because there's 60 seconds in a minute, that'll tell me the number of minutes. 120 seconds, that's 2 minutes. 125 seconds, well, that's 2 minutes and 5 seconds, but it's two full minutes. Okay? So we know how to get the minutes. For that, we take the seconds and we div them by 60. How do we get the seconds? We use the mod operator. We say how many seconds are left over after you divide it by 60 to get rid of the whole minutes. Then you're left with this other part, the number of seconds. And now, for those of you who have programmed before, you're going to see something that, oddly enough, you don't see in many other programming languages. In Python, you can return pairs or triples or four items at a time. So here we're going to return a pair, the minutes and the seconds. So 90 seconds expressed in minutes and seconds. That's 1 minute, 30 seconds. So we get this pair. First part is the number of minutes. The second part is the number of seconds. 2,000 seconds, or 2,000 seconds. 33 minutes, 20 seconds. 3,600 seconds. 60 minutes. 0 seconds, so 1 hour. Okay, so now we have this code, which you could see using internally in your microwave, which has this counter S, which is counting seconds down, and it's displaying not the number of seconds left, because we don't usually work that way. People don't work that way. It's displaying it in a much nicer way: number of minutes, number of seconds. Okay. Was there a question? Okay. So I'm a little bit fussy about these things. So here we introduced two variables, minutes, and we actually redefined the argument s here. There's really no need for that. This whole thing is a one-liner. You take s divided by 60 and s mod 60. That does the same thing. We don't need to to keep those around. There's not really a reason, no good reason not to, except that you get a little bit less code to read. Okay. Is that clear? Easy? Not clear? So now's the time to ask a question. What's that? Okay, comments. There's two ways. One of them is to use this hash character. That just gets skipped over by the interpreter. This is not the right way to do it if you're writing functions like this. The recommended way of doing it if you're writing functions is to have 3 quotes, 3 double quotes, and then say something about the function. So in this case, you might say, computes the area of a circle of radius r. Okay. Has absolutely no effect on the code, but somebody who reads this now knows what this function does. Yep. Yep. So the question is, why this crazy command line? Well, Python, because I want to fire up the Python interpreter. Minus q new. This is really all one argument. Minus q new. Use the new rules for division. And minus I is a separate argument that says, even though you're reading this file, once you're done reading it, go into this interactive mode. If I leave out the minus I, then it reads the file and then exits immediately. And there's no code in here that actually executes in this file except for defining pi, and so it's over. You don't get to test your functions. Yep.
Are you calling that line in the command?
This thing here?
Yeah.
What are you asking about it?
How do you get it? How do you get that?
How do you get this terminal, you mean?
Yeah.
Okay, so what kind of OS do you have? Windows? You have a thing on there called PowerShell. So don't search for it in the menus. Just do use the Windows key and then the run command. Just type PowerShell. You should get it on recent versions of Windows. Yep. Where is day 1 pi saved? Should be. Let's see. Did you go through the course webpage? So I'm actually getting my internet connection through my phone right now. It's not terribly fast. Code that we write in class, 0904, September 4th, and there's day1.py. Oh, on my computer, it's just saved in a directory that I created called 0904. Happens to be in a special subdirectory that that is being synced with this online server. So it's whatever directory I happen to be in. So for those kinds of things, it's worth having a look at this command line crash course. So go to Learn Python the Hard Way. One of the first things that you see there is this command line crash course, as well as information on setting up Python. And I'll leave you guys with an exercise. And that's to finish this piece of code here. What's that? Yep.
How picky are you about formatting? Like, when we define functions, do you want us to use underscores, or can we just make each new word start with a capital letter?
I would like you to use underscores because that's the standard way of doing things in Python. So I'll put in the comments for these in the last couple of minutes. And I want you guys to do this last one, this exercise for you. Actually, the real exercise will be just getting Python up and running and working from the command line. But if you've already done all that, finish this function that not only converts the seconds to minutes and seconds, but actually gives you hours, minutes, and seconds. And that's it for today. See you again on Tuesday.